look at the recursive form and some special sequences. The recursive forms basically mean what are you doing to one term to get to the next term, and so on. What we have here at the very beginning is a very famous sequence. We have 1, 1, 2, 3, 5, 8, 7. It's called the Fibonacci sequence. This pattern does show up in nature quite a bit. But if you don't see the pattern right away, it's really taking this term plus this term to get to this one. So you're taking two terms, adding them together to get the next. So you take these two terms to add together to get this one. You take these two terms to add together to get this one. You take these two terms, add together to get you the 8. And then the 8 plus the 5 is the 13. And then the 8 plus the 13 is the 21. The 13 plus 21 is the 34, and so on, and so on, and so on. Now, there's no easy way to represent the general form of this one right here, of our Fibonacci sequence. It's more easily represented in a recursive form, as in, what are you doing to one term to get to the next term? So we would write a sub n plus 1 equals a sub n plus a sub n minus 1. The a sub n term right here, the subscript is one smaller than what we started with here. So that means it represents the previous term. The a sub n minus 1, the minus 1 is also in the subscript. That's n minus 1 is really two numbers smaller than this. So that means it's your second previous term. So this notation right here means take your previous term plus your second previous term and add them together to get your next term. The only thing is, you would need to know where you started. So you need to state your first term, and since we're using two terms to get to the next one, you need to state your second term. If you did not state where you were starting, you would not know what sequence you would get. So you must state where you are starting in addition to the rule of what you're doing to get to the next term. Now, the Fibonacci sequence up here could be represented in a general form. I had said earlier that there was no nice general form. Now, the Fibonacci sequence can be determined and worked out with this right here. However, I would not say it's real nice, but it's interesting. You have square roots of 5, you have fractions, and you have exponents. And when you plug these in to be able to get your terms, you get nice, neat numbers without fractions, without roots, and no exponents. Now, let's consider this right here. The first part right here is your rule that you would use for the Fibonacci sequence. But suppose we said we're going to not start at 1 and 1. We're going to start out at 4 and 12. So if you were listing these out, you'd start out with 4 for your first term because you're given that. You'd start out with 12 for your second term. And then your rule says add your two previous terms together to get to your next one. So I'd have to take the 4 plus 12 to get to 16. Or the 12 plus the 16 to get to 28. Or the 16 plus the 28 to get to the next term. Now you notice what we have here in red is totally different than what we had up here in the original Fibonacci sequence. That's because we started out at a different position or different numbers. So that's why it's always important for any recursive form to start out with your given location. So let's find the first four terms. Well, that's easy for the first one because you're given that. And then we look at this. Our subscript's one smaller than that, so it means our previous term. So our rule says double your previous term and add 7. So my previous term's 5. My rule says I need to double that, which is 10. Add 7, I get 17. Then my rule says I need to take 2 and double that, 17, and add 7 to get to the next term. And then I need to double that and add 7 to get to my fourth term. Looking over here, I'm starting out at 2, so that's my first term. Then my rule says 3 times my previous term plus 1. So I need to go 3 times my previous term of 2 and add 2. I think I said plus 1. Sorry about that. So 3 times 2 plus 2 is 8. Then I got to go 3 times my previous term of 8 and add 2 to get to my next term. Then 3 times 26 plus 2 to get to my fourth term. Now, consider this one. A sub n is still representing my previous term. So I need to go 2 times my previous term minus 2 times n. Ooh, n. N is really the position of that previous term. So I'm going to start out with 3. Then I'm going to follow my rule. 2 times my previous term. Well, to get to my second term, my previous term was 3. So I'll go 2 times 3 plus or minus 2 times the position of that previous term. The position of this previous term is in the first position because it's 1. And so then I get 4. So my second term is 4. Now I need to go ahead and take 4 and plug that in. So I'll go 2 times my previous term of 4 minus 2 times the position of that term of 4, which is the second position. And so I work that out and I get 0. So now I need to go 2 times 0, 2 times the previous term, minus 2 times the position of that previous term of 0, which is the third position. So I get minus 6. Then I'm going to go ahead and plug in that minus 6 to get to my next term. Minus 6 times 2, because I need to double the previous term, minus 2 times the position of that 6, which was the fourth position. And so I work that out, and I would get minus 20. When you're dealing with functions, that iterative process, basically doing the same rule over and over again, taking what you get, plugging it back into your rule, taking that answer, plugging it back into your rule, that's an iterative process. That iterative process also works with functions. So here's our rule, here's our initial term. So we need to write these out. So we have our initial term of 5. Oops, sorry about that. And we got to take 5 and plug it in. Well, 3 times 5 minus 1, 3 times 5 minus 1, and we get 14. So 14's our next term. Now we got to take our 14 and plug it into our rule. 3 times 14 minus 1. So we get 3 times 14 minus 1, and that gives us 41. That's our second term. Now we got to take that 41 and plug it back into our rule. So 3 times 41 minus 1, and that gives us 122. That's our third term. So these are the first 3 iterates of this function. Try to do this one here quickly on your own. So you're going to take 2, plug it in. 2 times 2 plus 1 is 5. So 5 is your first term. Take 5, plug it in. 2 times 5 plus 1. And that's 11. That's your second term. Take 11, plug it in. 2 times 11 plus 1. That's your next term, or your third term. So we have 5, 11, and 23 for your next 3 terms.